Hello everyone, today we'll talk about the solution of the problem word subsets. When we read the statement and we try to figure out what this problem is actually asking us to do, it turns out that it's not very difficult. We are trying to check something independently for every string in words of one, and the final result will be every word from words one if some condition is satisfied. So that is one part that makes it easier. And another is that we want that word to be universal, which means that for every string B in words 2, B has to be a subset of A. Being a subset in this case means that the number of occurrences of every letter in the word from words 2 is at most equal the number of occurrences of that letter in the given word from words 1. And really, this being a subset is the same thing as greater or equal or lower than equal when just comparing counters or dictionaries. So indeed, we can take a word and create a counter from that word. That would be a dictionary that counts the number of occurrences of every letter. And we want the number of occurrences of every letter in the given word from words 1, this candidate for a universal word, to be greater than or equal to some requirement count. And now this requirement count is the final piece of the puzzle. Since we want for every word in words 2 to be a subset, you can just calculate the counter for every word in words 2. So we just calculate that counter. And we'll also maintain a global counter, and that counter will just maintain the maximum of the count of the given letter in all the words from words 2. So for every character and its value, the global requirement for that character is the maximum of the previous global requirement and the global requirement for the given word. And the reason why this works is that for a given word in this words 2, for every letter it has to appear at most the number of times that we have in this counter of word from word 1, which means that we are just checking for every letter that the appropriate value is less than or equal, which means that instead of checking it for every word from words 2 separately, we can just figure out how many times each letter appears at most in any word from words 2 and check only that. And this is indeed what this counter rex is doing. So again, we'll be maintaining a counter that counts for every letter the number of times it appears in a word from words 2 where it appears the most often. And for every word in word 1, this is the correct universal word if the letters in that word are greater than or equal than this global requirement.